For each and every chapter, not for we have TLM not for each chapter. Some of the chapters we have prepared for that TLM and charts. Now first class 6. Now in class 6, in the physics portion, there is element and compound and atoms, molecules. They have no idea about atom and molecules, elements and compounds. That's why we have prepared a chart like this card. So this card we can show hydrogen atom, one atom and two atom make a molecule. Like that, oxygen atom, nitrogen atom, carbon atom, diatomic molecules, monoatomic molecule, and after that we can show that compound. That means water. Water is made up of hydrogen and oxygen, all of you know, but for class 6 students today, we have made like this. One oxygen atom, two hydrogen atom. And I have draw the bond also here, but they are not, they do not know what is bond. So we can say that they have two hand, one hand like that. And carbon dioxide and ammonia. These three models I have prepared for class 6. Now last year, so this type of model, each and every year actually I give them to make this as a project with the thermocol ball. So for class 6, last year for machine and lever, they made class 1 lever, class 2 lever and class 3 lever. And they take the photograph and submit me. I have signed and they show them. They also showed me the original model also. And after that, I have thought maybe it may be missed. That's why I have collected all the photographs of their models. Now for counterbalance, this model they have made. For nut cutter, for forceps, and the waste dustbin type cart like that, one drill. They have made very nicely. I have seen that. All of their models, some of them maybe not good, but all the models were very nice. Like candle, and I cover it. The candle is there is flame. Candle is burning. Now, if I cover it with the glass, after some time, what I will see, observe. After some time, it will put on. That means due to the lack of oxygen, candle is put off. And with this experiment, what we can explain? Number 1, oxygen helps in burning. Number 2, there is two types of changes. One is physical change as well as chemical change. Physical change means candle is burning and some melting of candle, and there is some carbon is deposited on the one side of the glass, bottom of the glass. So we can take this carbon and show them this is what is this is carbon. That means this is a compound made up of carbon and hydrogen. So there is also chemical change, and for this chemical change some carbon is deposited on the upper portion of the glass here, and some portion of the candle is vaporized as water vapor. So this is also this experiment we can show them three types. One is oxygen helps in burning, chemical change as well as physical change, and also air is mixture. How? Oxygen is needed for burning, and easily oxygen is separated from the air and helps in burning. That means oxygen in air is not exist as a compound, but it exists as a as an element. So these three type of changes and properties we can show with this diagram. Prepared a pinhole camera. Each and every year, our students, our girls, prepare this pinhole camera, and all of you know, I don't need to show you, there is a hole, and we can read this candle, and we get the and by pushing, increasing the distance, just like this, we can show them that how the images is changing. So these three are this is for class 7. Next, Arpita will continue for class 7.
For the reflection of light, we have needed just three things. Just mirror, one mirror will be there. This is a plain cardboard. We have wrapped it. This is a torch, nothing is there in between, just a working model, and here we have put an eye. So now the next thing we will do, we have taken a laser light. We have taken a laser torch. We are putting it over here, and we will see that there is a reflection of light from there. If we put inside also, we can see there is a light is being reflected here. So this is a basic model of the reflection of light, which will also help them to understand the angle of incidence will be equal to the angle of reflection. If we draw here a normal, then if I change the angle, what will be? The angle will be also changing. So angle of incidence and angle of reflection concept will also be there for this model. If we draw the incident ray, reflected ray and the normal. So this is the basic one. Another for class 7 was the basic structure of the atomic model. Whenever we are teaching class, what happens that we can only draw in 2D. They can't understand what is the 3D. They have a concept of length, height. They doesn't have the concept of the breadth. This is a 3D structure of the model. What it is? That there will be electron in the orbit. We can say that this is a normal where in their home we can find it easily. This is the plastic balls which will be in the nucleus, which is at the middle. As of now, they will read only that the nucleus is at the middle because they doesn't have the concept of the solar field yet. They will need to learn in class 11, 12. So we can make it as of it orbital or circular also. That in the outer sector there will be just the electrons and the inside there will be proton and neutrons. They can make it for the hydrogen also, there will be one electron only, so that will be make it cheaper. If anyone thinks that making these models are very much cost, now this will be for any of that, from potassium, chlorine and everything they can make it.
In each chapter, no more. We have made a chart. Always we actually, with the help of this chart, we show that these are the two types of thermometer: Celsius thermometer and Fahrenheit thermometer, and lower fixed point, upper fixed point, and the fundamental interval. We can show them with the help of this chart. Other than that, in HIT we didn't prepare any model, but if we can try, then we can prepare this. Next.
Yes.
Demonstrating the experimental competition, contact force and non-contact force. Now, in the contact force, within this contact force, these two papers we can, this way we can, I have forgotten. We can show with these two copies that how frictional force is increasing. We have kept page under page, some of the pages. So we have increased the frictional force. That's why take it out, try to take it out, and friction is very much there. That's why you cannot take it out very easily. But if I keep it, show them only one page, it will be easily taken out. Okay. This way we can show the contact force, one of the contact force friction, other pulling force, pushing force with the help of our live chair, table. For each and every things we can show. Another thing, non-contact force. There are different non-contact force. So a model I have made with the help of globe, and as gravitational force cannot be shown with this small model, that's why I have used magnet, and along this straight line gravitational force acts like this. So non-contact force. So non-contact force, there is no contact, but Earth attracts everyone. It is shown with any of the object that we can throw anything on the upwards and it is coming down. We can show it in this. And next, so same pole, it will not attract people, and the opposite pole attract each other with these two magnets, and a magnetic substance like this, and it is attracting this. This line, with the use of two magnets, it is very easy. All of you know, we know that.
We teach them about pressure and we teach them about the lateral pressure. So what is lateral pressure basically? Liquid exerts pressure on the walls of the container. So that is called the lateral pressure, and on which factors lateral pressure depends. So we have made 3 holes. So we generally teach them that pressure increases with increasing depth. So we have made 3 holes here, and we will see the range here. So you can see that from this hole the range of the liquid is going traveling far. Now you can see the lower one. It is traveling far from this. The upper one, the range is decreasing and it is just rolling down along the wall of the container. So we can show them that with increasing depth, pressure also increases. Now the next thing is that nowadays there is a concept of give reason questions. Then sometimes students just mark up what is pressure, what is lateral pressure, P equals to H rho G. They doesn't understand what is the meaning of that. Or we normally say in the class that everything flows to it is moving from the high pressure to the lower pressure area. So what is happening here, we can use a simple experiment. What it is that I am putting a straw inside. So if I sip it, what will happen? That water will flow through the pipe and I will get that in my mouth. If I put both the straws, what will happen? From both the straw, water will be there and it will reach my mouth. Now the next thing is that what it is, when I am sucking the pipe, what will happen? The air inside the pipe will flow in my mouth. There is a creation of the low pressure and the water from there will reach my mouth. Now the next thing we can ask the students that join both the pipes at the upper end and try to sip it out. What will happen? They will expect that from one straw the water will be there, from another straw nothing will be there, so water will flow. But in real life we will see that it is not the case. When we are sipping it, from none of the straw the water will flow. Why it is? When I am sucking this pipe, what it is coming? There is nothing means there is air. Air is moving inside that straw. From that straw it is entering the green one. So water can't get any low pressure area. So it can't reach our mouth. So from this kind of experiment, they will understand how refraction. In class 8 there is some other concepts, and in class 9 we read, in class 10 in chapter light we read up to Snell's law. Now, when there is no medium, okay, so what we can see, that we can clearly see the pencil in a straight line. How the pencil is aligned? It is along a straight line. But when there is water, we have taken water. So now I am dipping the pencil inside. So what we draw, that when light is passing from rarer medium to denser medium, the refracted ray is, yes, it comes along the normal. So you can see it feels like it's broken actually, but it is not. It is happening due to refraction. It also is increasing actually, we can see. So this can be shown when we just take a shower. A bucket full of water. If we put our hand down, it will appear the hand is actually way more above than it actually is. So in that way also I generally ask students to do it by themselves, to understand what is actually everyday life we are observing these phenomena. They are just introduced with the apparatus which are being used in the chemical lab. So we can show them that this is the beaker. This can be used for making any kind of solution with the help of a glass rod. This is a measuring cylinder. Any liquid we can measure the volume. There are various measuring cylinders. This is a 25 ml measuring cylinder. It can be 50 ml, it can be 100 ml, it can be up to anything actually, depending on the amount of the liquid we want to measure. Now, this is the volumetric flask. Now, what is the use of it? It is basically used for making the solution. Basically, to be very precise, in 11-12, we use it to make standard solutions. Standard solution of generally primary standard solution, not the secondary standard, because you can see there is a mark there. So the whatever solid we are putting here by exact measuring or exact measurement, and then we have to fill water.
If we use the term primary standard.
No, this is I am telling you, not the students. I have already mentioned it can be. This is used in elementary
Students will ask now what is primary standard. They want to
then I can explain them as well that what is primary standard. Yes, ma'am. Very sorry. So what is primary standard? Their strength means their strength will not change with respect to time. They will not react with the atmospheric conditions.
That you have to tell also.
And then it is the conical. They have the basic introduction of titration there. So we can show them that it is being kept, downwards the burette, and it is used for the titration. And this is test tube. So now up to class 10, I don't think we can use test tube. 11-12 we can use test tube because there are various experiments there.
We can show.
Actually, there is a chapter called separation. We can use there also by putting a filter paper here. So we don't have any filter paper, so we cannot show it right now. But putting a filter paper, we can exactly show them that how the filtration can be done by using it.
Filtration, decantation can also be done.
Yes.
Decantation with the rod, glass rod, sedimentation rod.
We will teach them that in solid, the molecules are very close to each other, that there is a very negligible intermolecular space among them. In liquids, there are more than that, and gases, the molecules are poles apart. Now, we can do the basic experiment like that. There is what I have taken the water and mixed the paint with it. And it has been melted with that, and it is mix of solution. Now, it is a saturated solution. Now, saturated solution means that it is normally the oversaturated. You can see that the salt a drop it is only at the upper part. It is not going downward. Why it is? There is liquid molecules and they are very close to each other, and there we have already mixed a lots of NaCl, and lots of NaCl takes up the space in between the water molecules. So now the color have no space to mix with each other. So this is how we can show them that how intermolecular is that there is already intermolecular space. Students nowadays ask, you can see that intermolecular space. We can use the compound microscope or electron microscope for seeing the atom or the intermolecular space. If we can't see that, how you know that there is a space? So this kind of experiments can reduce this kind of queries. After Newton's law of motion. Now from the Newton's law of motion, from the first law we get the concept of the first one, rest condition and the motion condition, that if we kick a ball that will move, and if we doesn't touch any non-living object, there will be rest for the infinite time period until and unless for any external force acts on it. So we can take on that with this example, that if you kick, you are giving an external force, and for that the ball will move. Otherwise that ball will not move any condition. This car is hitting the wall. This concept is shown the inertia, that as much as the mass will be more, the velocity will be more, the impact on the wall will be more. That momentum is proportional for both the mass and velocity. For the next, force equals to mass into acceleration. Newton's second law states that only. The mathematical form of that is force equals to mass into acceleration. So this person is trying to push the stone. So what happened? He is applying the force. That is why there will be a creation of acceleration on the stone, and that will move. The next is that the Newton's third law of motion, and every action there will be an equal and opposite reaction. We can show that if there are very much practical examples, that whenever any bullets are coming out from the gun will move in the backward. We can give the another live examples also, like when they are traveling through a boat, that when they jump on the boat and they will be moved backwards. So there will be, this will be the basic 3 times of law they can get from this chart. That what is the take on Newton's 3 laws.
Lemon, I am giving it and it is sinking. Next, with the help of saline water, what it will show? It will floating under the water. Just very simple experiment. And saline water density is increasing, and gradually density is normal water, density increases. The density of this water is more than that of the previous one, and this is some of the part of the lemon is above the water. So this experiment we can show the buoyancy, and why the ball is going upward, we can explain all of us. Another thing we can do with the help of irregular shaped body. Any irregular shaped body, we can, with the help of a measuring cylinder, we can put it into the water, and the water level will increase automatically, and by reducing the height, we can find out the volume of this substance. And with the help of weighing machine, common balance, there is a common balance. I have done in my laboratory with my students of class 9. Take this weight, mass, and mass divided by volume. Displaced water, we can find out the density of that substance. That means first we put this. This is the reading body, the height will be already the height will increase. The displaced water, volume of the displaced water we can find out, and we can take the mass of this with the this is a very weighing machine. So with the help of mass, this machine we can take the weight of this substance and mass by volume. We can find out the density of that substance. In the biology chapter, the first chapter, from the first chapter, many things we can find out, and many things students can do. Number one, volume of the substance, density of the substance, to find out the density of the substance, to find out the thickness of a page. It is very easy, thickness of a page. And I have done another thing in my class. I told them take the stopwatch and rate of flow and fill a bottle with water. And rate of water, it is very easy to find out.
There are chapters of measurement and errors, and there is the thing called list count. So I actually had shown them with the help of this meter scale that what the list count is. So we can see here that what is the minimum measurement we can take in the meter scale. Actually it is 1 millimeter, because each gap is 1 centimeter and there are 10 small divisions. So we can show them that this is the list count of a meter scale. So the minimum measurement we can measure in any instrument, that becomes the list count. Now coming to errors, like how errors develop. For the meter scale, first if we want to measure something, we need to place the meter scale and our eye perpendicularly align what we are actually measuring. And suppose I am just measuring the length, so I have to match any of the edges. Sorry, this is broken, but so we have to match the edges with any particular mark. It cannot be very random. So here from the errors occur. So when the error is being done by the observers or the expert who is doing the experiment from this side, then we can call it the personal error, because I am doing like this and some mistakes are being made. So this is happening because of my negligence. So we can call them the personal error. Maybe the actual 1 centimeter value is not properly measured in the instrument itself. So we can call it the instrumental error. And suppose the matching is not being done properly, so we can call them the experimental error, the errors occurring due to the wrong steps in the experiments.
Class 7 there was the atomic structure. Again in class 9 we are getting the atomic structure, and again there will be some real life problems in the classroom that they ask normally. We read the Rutherford, now why I will read the board? If the palm pudding model is wrong, then why we will study the palm pudding model? So to make them understand that science is not about the result, it evolves with the time. There is a chart of evolution of atoms. So from the 400 BC, how we are seeing the atoms. See, the first was given by the Dalton, where there is an atom at invisible and compound combinations of different type of atoms. We don't know till now then that there is the proton, electron and neutron. They come up very later. Then the Thomson's palm pudding model, and then there will be what happened, that till now there is no concept of neutron, because it is very hard to find the neutron for them because it doesn't have any charge. Proton and neutron, there is charge, so they are repelled with each other with the electric field. It is easier to find for them. So they have found that the protons, which are at the middle, this is the first step, that the nucleus is at the middle and the electrons are at the side. So he has said that there is a K in the
middle there will be proton, and the dry foods will be electrons. Next, the nuclear model, the Rutherford one, which we have recognized with the utmost supremacy that the Rutherford has given, that the structure we have made with the 3D, that again that time of time also there is no concept of the neutron, and there will be proton at the middle and the electron will be revolved, just a little bit more evolved than the Thomson's sperm proton. Planetary model that given by the board, at that time there is a concept of the neutron. He has first said that the protons, from the concept we can also say that in the force we have to read that same type of charges repel each other. So in the nucleus we are continuously saying that the protons are together, protons and neutrons are together. So protons are all the positive charges, so they should repel each other. How they are binded at the small place of nucleus. So from there we can also say that the nuclear force, which is more powerful than the static electric force. A little bit of the essence of the Schrodinger's model, that now we only concept that at the nucleus there are proton and neutrons and electrons are clouds of that. That is an n-dimensional thing around the nucleus which are revolving. So from this we can show that. Next is that there is a chart of motion in one dimension. This is not only for class 9, this is also actually important for class 11, where we can show that they will read from class 11, they will start learning that how from displacement we can calculate the velocity, from velocity there will be acceleration, but in class 9 they will just read that displacement, what it is when there is a distance in a particular direction. When you mention the direction, there will be a displacement. And in velocity, same. It is a vector quantity. It has the direction, speed, but in a particular direction. They will get the acceleration. So how, with time, if there is constant velocity, that is, with time the velocity is not changing, it shows a straight line. That with time its value doesn't change, it doesn't go up and down. We can show that. See, this one will be moving with the decreasing acceleration. That means speed is being reduced. The velocity is being reduced with the time. This will show the non-uniform motion. The concept of uniform and non-uniform motion also can be explained. That for this, in equal time interval, there will be equal distance traveled. But in this case, that will be not. And that there will be concept of the slopes also. That if around in class 10 they learn about the tan theta, but before that they know that y by x. So we can explain that when the tan theta, where the slope is constant, that any point of time if we draw a triangle, if it is same, then it is the uniform motion. And here in every triangle the answer will not match up with each other. So this is a kind of non-uniform motion. So from motion in 1D we can pick up all that. They can make it all the graphs and make it for them. In class 10 also they can make for the behavior of gases all the graphs in one page. So they can see from every day that what the graphs are there. Another thing which we have made is that separation of the substances. In class 9 that is there also. There will be, here I have shown all that solid mixture, there this can be, we can that with by sieving, we can trashing, we can hand picking. There are multiple processes. From them what will happen that they will learn the examples, that which one can be solved by which. This one will show the liquid mixture, that distillation. While when we do the distillation, here it is written when two components have two different boiling points, they can do the solid liquid mixture. Here in this chart what will be the helpful is that they will learn the examples, which kind of materials can be separated by this, what is the course, why I am doing it by the evaporation, not by the distillation. They can also learn from this chart.
So one thing I have forgotten to show you, with the help of 2 mirror in the class 8 also, we can show them that with the increasing angle, the only 2 mirror, there is only 2 images, as 2 images are, as we decreasing the angle, the number of images Very simple experiment, very simple, but they will be encouraged enough to find out the angle also, or number of images also
Of the organic chemistry chapter. Now, when we talk about the term organic, what comes to our mind? That organic molecules comprises basically carbon, hydrogen. The basic one I am telling you, that without carbon organic molecules are not possible. Now, carbon is having 4 valence electron. Now, how the valency is arranged in a 3-dimensional space. When we tell them that methane is the elementary alkane, so we tell them that okay, methane structure it is tetrahedral, there is no double bond, only single bonds are involved because it is made up of only carbon and hydrogen, and we all know that hydrogen is having only 1 electron in its outermost shell. So what it is actually in a 3-dimensional space, basically it is the tetrahedral structure. We call it the tetrahedral structure. We can clearly see that this bond is above the plane. So from this we can tell them that these bonds are actually 109 degrees and 28 minutes. We can clearly show them that had it been like this, it would have been 90 degrees, and it is more than 90 degrees. Ethene or ethylene, the concept of double bond. So here we can show them basically bonding concept we will show by another chart. So we are focusing here only on the organic molecules. So when it is ethene or ethylene, obviously it cannot be with the help of 1 carbon atom because we know that it means 2. So we must need 2 carbon atoms. So here there is a double bond, and for each carbon atom 4 valencies need to be adjusted. So here, as we have shown here, that we call it the 4 hands of the carbon. So here 1, 2, 3, 4, 1, 2, 3, 4. So each carbon is having 4 valency. Now another thing we can show that single bonds are, we can rotate them. These are rotable, and double bond is rigid. It will either twist it or it will just break. So we cannot basically twist it or rotate it. This is a very rigid structure. Bonding concept. So bonding means basically how 2 atoms are combining or making a bond to make a molecule. Now there are basically in class 10 there are only ionic bonding and covalent bonding. There are other one type of bonding that is called coordinate bonding, but that is from the class 11 syllabus. So we will just focus on the ionic bonding and covalent bonding. So basically what ionic bonding means? Ionic bonding means in the name itself there is a name called ions. So we know from class 7 that how ions are formed. A charged atom is called an ion. So what will happen here? Lithium and fluorine. So this is a metal. What a metal is? Generally metals are very much electropositive, means it can easily donate its electrons and get the electronic configuration of the nearest noble gas, that is H electron in the valence shell. So here is lithium. In the inner shell there is 2 electrons and it is 1 electron. So if that is removed, it is the electronic configuration of the nearest noble gas, that is helium. And fluorine, we can see that there are 7 electrons in the outermost shell. Now if this electron goes there, then the stability factor or that problem is solving, because it can get rid of that atom and become stable, and everyone wants to be stable, and it also can take up this electron, and actually which I have shown in the next step. So it also can take up this electron and fulfill its
what I mean to say that sharing. So here no one will give anything to another one and another will accept completely that. Here we are like friends and we will share electrons. Means whenever it is needed, we can use them and call it, okay, these 2 are mine or these 8 are mine. So let me show you. It is hydrogen having only 1 electron. Now it is chlorine having 7 electrons in the outermost shell. What happens? They come closer and this bonding happens. Means, so this is the electron of hydrogen and this is the electron of chlorine. So whenever it is needed, basically everyone wants to complete this octet, though it is not true for hydrogen because it cannot complete that because it is having, it can get up to only 2. So by sharing it, whenever this is needed, hydrogen can say, okay, I have 2 electrons. So I will get the electronic configuration as helium. And whenever needed, chlorine can also say, okay, this is also mine. I can show that I also am having 8 electrons in the outermost shell. So there is equal sharing. Now the concept of covalent bonding, like single covalent bond, as I have shown here. So 1 electron from each side is being shared. 1 electron from hydrogen side and another electron from chlorine side. So it will make a single bond. 1 electron from each of the atoms. Now coming to oxygen. So we know that the electronic configuration, there are 6 electrons in the outermost shell of oxygen. So how much it needs? How many electrons do it need to complete this octet? Only 2. So in case of oxygen molecules, if just 2 electrons are shared, so we can say that, sorry, the other 2 has dropped. So it should have been actually 2 from each side. I am very sorry for that. So 1, 2, 3, 4, 5, 6, 7, 8 and this one. And when nitrogen from 3 it is being done, from 3 from each side, basically 3 bonds will be there.
Excuse me, that's supposed to be there. Here I have prepared the model of having the different layers of atmosphere. Showing the different layers of atmosphere, troposphere, stratosphere, and according to that, mesosphere, ionosphere, thermosphere, and exosphere. In each sphere, if we give them the that in the troposphere, storms, cloud, rain, all are happening in the troposphere. In the stratosphere, UV rays are absorbed. With this chart, then it is clear to all. And on this chapter, I have given them a project in the class. Draw this atmosphere, and after that, you will write down the questions with this diagram. Draw first diagram, and then write down the questions and write down the answer. The questions will be different for different students. That is one class I have given. Written down all these gases in this manner. How ozone layer is affected by chlorofluorocarbon, and which atom is very important for this depletion of ozone layer. And in this way, I have written down in this way. That's why they are easily understood that how ozone layer is depleted. So with this chart, I have extended if the pressure is low, then the volume is increased, and slow by slow, it is pressure is increasing and volume is decreasing. Pressure is again increasing and the volume is decreasing. In this way, and they have drawn the graph of Boyle's law, PV versus P graph, P versus V graph, and V versus 1 by V graph. In the class, I have given the graph also. I have given some data to them. This is the data. These are the data. Draw